Multiplying fractions. To many people, it might not be clear what something like 2/3 multiplied by 1/4 means. So, before we talk about multiplying fractions, let's think a bit about multiplication itself. Normally, we think of multiplication as involving whole numbers. You are trying to solve problems like 2 times 3, which equals 6, or 7 times 4, which is 28. If you buy 3 packs of canned soda, how many cans do you have? There are 3 packs of 6 cans, 3 times 6. We can count them all up. There are 18 cans of soda. But let's think about multiplication in a different way than we do when buying cans of soda. Let's think of it as the area of 2 numbers. Here's a house. It's a pretty small house, only 1 room, and we need to buy some carpet for it. How many square feet of carpet do we need to buy to cover the bare floor? This house is only 10 feet by 15 feet. So, how many square feet of carpeting do we need to buy? The way to find the area of a rectangle is to multiply the width by the height. In this case, it's 15 by 10 feet, which is equal to 150 square feet. The answer to a multiplication problem can be thought of as the area of a rectangle whose width and height are the numbers being multiplied. We aren't necessarily talking about floor plans or cans of soda now. We are just trying to come up with a useful way of thinking about how to solve a multiplication problem. You're probably thinking, this is all great, but what does it have to do with multiplying fractions? Let's start with a square. This square is 1 unit wide and 1 unit tall, which makes its area 1 square unit. We aren't going to worry about what size units are. It could be inches, meters, kilometers, or light years. Personally, I'm going to think of these units as square meters, but you do you. The important fact, though, is that this square is 1 wide, 1 tall, and this is 1 whole square. Now that we've got that settled, let's bring back our fraction multiplication problem from earlier. 2/3 times 1/4. Let's take a marker and divide our square into 3 equal-sized parts. 1, 2, 3. Since the square hasn't changed size, the height of these sections we've marked off are still 1. But the widths are now 1/3 of the width of the whole square. So each section is 1/3 wide and 1 tall. To get the area of each section, we just multiply the width by the height. 1 times 1/3 is 1/3, because 1 times anything is the same thing. Since our first fraction is 2/3, we can paint the first 2 of the 1/3 sections red. Look at that! We've got our 2/3. That's the first fraction of our multiplication problem. We can make our second fraction the same way. But this time, let's make the marker lines go horizontal instead of vertical. Each of these new horizontal sections are 1/4 tall and 1 wide. And if we paint one of them, say, yellow, we can see that the bottom section is 1 wide and 1/4 in height, which means that the yellow area is 1/4 in area. 1 times 1/4 is 1, and that's our second fraction. Look! As the paint's dried, some of the red paint has seeped into the yellow paint. We've got an orange section, as well as red and yellow sections. That orange section is the overlap between our 2 fractions, and it looks to me like the width is 2/3 and the height is 1/4. That's our 2 fractions, which means that the orange rectangles are what we get when we multiply our 2 fractions. But how do we know what the area is in terms of a fraction? Well, those dividing lines we drew with the marker has divided the 1 unit square into equal-sized rectangles. And there are 12 of them. So each one of those rectangles are 1/12 of the 1 unit square. And there are 2 of the little rectangles in the orange area, which means that the orange area is, drumroll please, 2/12. And that's the answer to our fraction multiplication problem. 2/3 times 1/4 is 2/12. So, does this mean that every time we need to multiply a fraction, we've got to make a square, get our markers and paint, and then wait for the paint to dry? Nope. Look at the problem. 2 times 1 is 2. 3 times 4 is 12. To multiply two fractions, all we have to do is multiply the top numbers, the numerators, together. This gives us the numerator for the answer. Then we multiply the bottom numbers, the denominators, together. This gives us the denominator for the answer. And that's a lot less work.